Let us see question number 6 from exercise 6.5. ABC is an equilateral triangle of side 2A. Find each of its altitude. Each of its altitude. So here given that ABC is an equilateral triangle. Equilateral triangle means what? As we know. So in the earlier classes we learned what is equilateral triangle. Yes, you are right. Equal sides and equal angles. All the three sides are equal as well as all three angles are also equal. So triangle ABC is an equilateral triangle. So here ABC, this is an equilateral triangle of side 2A. Each side is how much? 2A units. Each side is 2A units. So this is 2A and this is also 2A and this is also 2A. So what exactly he is asking? Find each of its altitude. What is the meaning of altitude? A perpendicular line drawn from vertex to its opposite side. Perpendicular line drawn from vertex to its opposite side. So draw the perpendicular. So perpendicular A, we look at D. And one more property we learned when we are talking about equilateral triangle. In equilateral triangle, we know that each what is that? Each in equilateral triangle, altitude as well as median both will be the same. What is exactly median? Median is nothing but midpoint from vertex to the midpoint of opposite side. This is only happens equilateral triangle. Altitude and median lies at the same point. That is one. Or you can say by using criteria, RHS criteria, you can prove these two triangles are congruent. Once the triangles are congruent, anyhow you get D is the midpoint of BC. That way also. But we know the property as in equilateral triangle, altitude and median are same. That means AD is a perpendicular bisector. So in equilateral triangle, given ABC is an equilateral triangle where AB is equals to BC is equals to CA is equals to 2A. So we have to find out, what we have to find out? AD. We have to find out AD. So each altitude, what is AD here? AD is the perpendicular solution. Observe it. Draw AD is the altitude means which is nothing but perpendicular. As we know in equilateral triangle, perpendicular altitude and the median are same. That means AD is perpendicular to BC and AD is the median also. So that means median also means D is the midpoint of BC. So BD is equals to DC and AD is perpendicular to BC. That is altitude. As it is altitude, perpendicular. As it is median, so BC is equals to BD is equals to D is the midpoint. So BD is equals to DC. So BD is equals to DC is equals to half of BC. So what is BD value? That we have to find out. Half of BC. So BD is equals to half of 2A, which is equals to A. So BD length is how much? BD length is how much? A. That means BDC also will be same. So here this is A and this is A. Now you have to find out AD, altitude length you have to find out. For that, apply Pythagoras property in any one triangle ABD or ACD. ABD or ACD. Now in triangle ADB, angle ADB is equals to 90 degrees. Now applying Pythagoras property in that. So that is AB square is equals to AD square plus BD square. AD square plus BD square by Pythagoras. By Pythagoras theorem. Now in that you see AB length we know that is 2A square. 2A, so whole square will come is equals to AD that we have to find out plus BD that is given we got as A square. So 2A whole square is nothing but 4A square is applicable for both inside the bracket is equals to AD square plus A square. Transpose A square this side, 4A square minus A square, which is equals to AD square. 4A and minus 1A. 4A square minus 1A square, which is equals to 3A square is equals to AD square. Now AD is equals to the inverse operation of root square is root 3A square. Inverse operation, that is root 3A square is equals to this. Square root is applicable for both. So root 3 into root A square is equals to AD. So root 3 and square root get cancelled, A. So AD is equals to root 3A. This is, we found AD. What he is asking, find each of it altitude. Like this, from B to AC if you construct altitude, similar procedure, and C to AB if you construct altitude. Because all the three sides are equal, it is an equilateral triangle. So similarly, we can prove all the altitudes like this. So similarly, each of its altitude is root 3a. Each altitude of it is root 3a. Is it clear? I hope you understood. Question number 8. In the given figure, O is a point in the interior of a triangle ABC. OD is perpendicular to BC, OE is perpendicular to AC, and OF is perpendicular to AB. Show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equals to AF square plus BD square plus CE square. In the diagram you can observe it. Second question, in that second bit, AF square plus BD square plus CE square is equals to AE square plus CD square plus BF square. Let us see this question number 8. In triangle ABC, OD is perpendicular to BC, OE is perpendicular to AC, and OF is perpendicular to AB. We have to prove that the first one and second one. To prove this, we require some construction, that is join OA, OB and OC. Okay, that is the construction. So construction. construction, join OA, OB and OC. We have to prove, join. Now proof. So these are all by Pythagoras property. As these are all right triangles, we are using the concept of Pythagoras property, Pythagoras theorem. So by Pythagoras theorem, now in triangle AOF, in triangle AOF or OFA, anything, OFA, in triangle OFA, in triangle OFA, by applying Pythagoras theorem, AO square is equals to, observe it, OF square plus AF square. This is, let this equation 1. Next, similarly, in triangle ODB, in triangle ODB, observe it, ODB, again by applying Pythagoras property, OB square is equals to OD square plus BD square, this is equation 2. Here also, instead of AO you can write as OA square, anything is okay. Now in triangle, observe it, in triangle OEC, again by Pythagoras theorem, OC square is equals to OE square plus EC square. This is equation 3. Now adding equation 1, equation 2 and equation 3, by adding equation 1, 2 and 3. So when we are adding these equations, we have to add LHS part LHS and RHS side we have to add. So here, that side you see, when we are adding equation 1, 2, 3, equation 1, equation 2 and equation 3, adding equation 1, equation 2, equation 3, what we have LHS side, OA square plus OB square plus OC square. So I am adding LHS, OA square plus OB square plus OC square is equals to, now coming to the point of RHS side, OF square plus AF square plus, second one you see, OB square, in this OD square, OF square plus AF square, that is the first one, plus second one you see, OD square plus BD square, plus, now the third one, OE square plus EC square, So the first one is this part RHS and the second one is this part and third one is this part, OE square plus EC square. Now when you see the equation which we need to prove, OA square plus OB square plus OC square, we have OA square plus OB square plus OC square. What we need? OD square. So transpose OD that side, then OE that side, then OF that side, then we will get, so here OA square plus OB square plus OC square, we are transposing this side, minus which are all required, OD square minus OE square minus OF square is equals to, what is left over this side? AF square is left over plus BD square is left over plus CE square is left over. We proved. We proved this one, first one. Now to prove second one, you see. Now this is the first one what we proved. To prove what is second one? To prove second one, which is equals to AF square plus BD square plus CE square is equals to AE square plus CD square plus BF square. This we have to prove second one. So to prove second one again by Pythagoras theorem. So by Pythagoras theorem. By Pythagoras theorem. So we are applying Pythagoras theorem again. Now we are considering triangle ODB and ODC. ODB and ODC. So consider the triangle now. In triangle ODB. In triangle ODB, apply Pythagoras property again. What do you get? OB square is equals to OB square is equals to OD square. OD square. OB square is equals to OD square plus BD square. This is equation 1. You see here, this part we are proving the second one. So in the second one, this is the equation 1. Next, again in triangle. In triangle ODC. 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 Again, OC square is equals to OC square is equals to OD square plus CD square. CD square. This is equation 2. Now by subtracting equation 2 from equation 1. Equation 2 from equation 1. So subtract 2, that is 2 means the second one, from 1. So from this you are subtracting this equation. Okay. Now when you subtract this one, what you get? LHS part. LHS side you will be getting OB square minus OC square is equals to, observe it clearly, first one OD square plus BD square minus of, again OD square plus CD square. OD square plus CD square. Here because two terms are there, we are using minus. Two terms are there, we are using bracket for that. Now when you simplify this part, OD square plus BD square minus OD square minus CD square plus, when you open the bracket, minus into plus, minus into plus, minus. So this side we got OB square minus OC square. Now you see here, one is OD plus OD minus OD. So they both gets cancelled. What is left over? We have OB square minus OC square is equals to OD square, BD square. OD is cancelled, so BD square minus CD square. Let this equation as 3. Equation as 3. Observe it clearly, this equation. So we subtracted second equation from first. We got one more equation. Let us continue that side. First you copy this. Now see the continuation of that. Now we are taking triangle OEC and OEA. Observe it. In triangle OEC, according to Pythagoras theorem, again OEC, OC square is equals to OE square plus AE square AE square. This is equation 4. Already 3 over with this. Next, in triangle OEA, OEC we took now. Now we are taking OEA. In triangle OEA, again OEA, apply Pythagoras property. OA square is equals to OE square plus, in triangle OEC here CE square or EC square. This is EC square or CE square. This one actually we used OEC triangle, so EC square. Are you following? EC square or CE square, you can write anything. Clear? OEC, observe it. In this OEC, OC square is equals to OE square plus EC square or CE square, which is given CE square. Let that equation 4. Now OEA, in that OA square is the hypotenuse, which is equals to OE square plus AE square. Let this equation 5. Now subtract 5 from 4. 5 from 4. We are subtracting 5 from 4th equation. So when you subtract from 4th equation, so first will come here OC square minus OA square is equals to OC square minus OA square is equals to, see here, OE square plus CE square minus of OE square plus AE square. Now open the bracket. So when you open the bracket here, OE square plus CE square minus OE square minus AE square. Here see clearly, OE square plus into minus into plus minus. So OE square cancel, OE square cancel. What do you have? CE square minus AE square. So here OC square minus OA square is equals to this. Now we'll write the equation what we got finally. OC square minus OA square is equals to CE square minus AE square. In all these places we are applying only Pythagoras and adding equation 1 or 2 or subtracting equation 1 or 2. Let this equation as 6. This equation. So now third equation you have to remember. Sixth equation you have to remember. Similarly, you get one more triangle, that is, so now in triangle, observe it, OFA and OFB, if we consider those two, in triangle OFA, again hypotenuse OA square, observe it, OA square is equals to OA square is equals to OF square plus AF square. Let this equation 6 over, now it is 7. There are so many equations. Okay. Now in triangle, these are all by applying Pythagoras concept only. In triangle OFB, again OB square is equals to OF square plus BF square. Let this equation 8. Now by subtract equation 8 from 7. Equation 8 from 7. You see here, equation 8 from 7. Okay. So now when we are subtracting, first will come, so OA square minus OB square, LHS side, OA square minus OB square is equals to OF square plus AF square minus of OF square plus BF square. Open the bracket. OF square plus AF square minus OF square, when you open the bracket, minus into plus, minus BF square. Now which is equals to OA square minus OB square. See here in this also we have again OF square cancel. So what is left over here? OA square minus OB square is equals to AF square minus BF square. Let this equation as 9. Let this equation as 9. Ninth equation. Now by adding 3, 6, 9. By adding 3, 6, 9 equations. By adding, now continuation of this part, by adding equation 3, equation 6 and 9. Equation 3, 6, 9. See here, we are adding equation 3, equation 6 and equation 9. So what is equation 3 here? We have equation 3, OB square minus OC square. So OB square minus OC square plus LHS part you see. OB square minus OC square, and here plus OC square minus OA square plus, and then here LHS part OA square minus OB square is equals to, these are all LHS parts of equations, equation 3, equation 6 and equation 9. Next, here you can write, instead of writing these many equations, similarly also you can write, now is equals to, what we have, RHS part BD square minus CD square. Here I am writing, so BD square minus CD square plus, then here CE square minus AE square. Here we forgot to write square. AE square, CE square minus AE square. So CE square minus AE square plus, observe it again. Next here AF square minus BF square. AF square minus BF square. AF square minus BF square. Now look at this. Here in LHS part you see plus OB square minus OB square cancel. Minus OC square plus OC square minus OA square plus OA square. So all the LHS terms are 0. They are making as 0 is equals to. Now we have RHS side BD square minus CD square plus CE square minus AE square plus AF square minus BF square. So whichever all are having minus, transpose towards LHS, then you will be getting, transpose this one LHS, then it will become CD square. Transpose this one plus, transpose this plus, so CD square plus AE square plus BF square is equals to this one you see. Now we have BD square plus CE square plus AF square. Therefore you can write AF square plus BD square plus CE square is equals to CE square. AF square plus BD square plus CE square is equals to AE square plus CD square plus BF square. This is how we prove. So to prove all this, which concept we are using? By applying only Pythagoras theorem and adding or subtracting the equations, we are approaching the result. Is it clear, students? Let us see question number 11. An aeroplane leaves an airport and flies due to north at speed of 1000 km per hour. At the same time, another aeroplane leaves at the same airport and flies due to west at speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? Let us see question number 11, which we have read now. So, one flight is moving towards the north. This is the north-south direction, east and west direction. North-south and east-west directions. Here we have. So, in this, one flight is moving towards the north, one flight is moving towards west. So, distance. Speed of the flight towards the north is 1000 kilometers. Speed of the flight towards the west is 1200 kilometers. After 1.5 hour, where they are going to meet? Where do they meet? After 1.5 hour, where they are going to meet, that we have to find out. So first, before that, distance, how much they will travel in 1.5 hour. For 1 hour, it is traveling towards 1000 kilometers. So distance is equals to speed into time. Distance is equals to speed into time. So now what we are doing, distance of towards, so north flight, let us, it is traveling up to the point A and up to the point B towards west. So join, we have to find out these two, how far they are after 1.5 hour. We have to calculate AB. So let us first flight distance traveled towards to distance traveled by the first flight towards north is equals to, distance is equals to speed into time, which is equals to speed into time. So this towards north is equals to, what is the speed? 1000 kilometers, 1000 into 1 by 2 hours, which is nothing but, you can convert this as 3 by 2 hours. So 3 by 2, so 2 ones are 2 5s are, which is equals to 1500 kilometers it travels after 1.5 hours. So OA is equals to 1500 kilometers. Next, distance traveled by the flight towards west is equals to, towards west it is traveling in 1.5 hour time. How much it travels? So 1200 into 3 by 2, 2 ones are 2 6 are, which is equals to, so 600 into 3, 1800 kilometers. So OB, from here, this is the airport, if you think, from here it is traveling 1800 kilometers. Now how far they travel, how far they will be, both the flights at after 1.5 hours. So we got this distance and we got this distance. Now we are using Pythagoras property in triangle AOB. In triangle AOB, observe it. In triangle AOB, you have to find out the distance traveled between AB. So AB square is equals to OA square plus OB square. So AB square is equals to OA is distance 1500 square plus OB 1800 square. So 1500 square is nothing but 15s are 225 and 200 plus 18 square. So 1800 into 1800, which will be given 18 into 18 as 324. So 324 000, which is equals to AB square. If you add these two, you will be obtaining 225 and 324. If you add 549 0000 AB square. Now AB is equals to, so to find out this AB, we can write as square root. So square root of 5490000. So easiest way, if you go for prime factorization, this can be written as, so 61 into 90,000. So 61 into 90,000, which will be giving as, so which is equals to root. So 90,000 is nothing but square root of 300. See, observe it, 90,000, 1000 into 9, you can write as 61 into 9 into 10,000 into 10,000 square root. So 9 square root is 3 into 10,000 square root is 100 into root 61, which is equals to 300 root 61 kilometers. So they both the flights will be apart from each other. So therefore both flights at 300 root 61 kilometer apart from each other after 1.5 hour. After 1.5 hour. See the 549, which one? When you add these two and prime factorization, if you do, this will be the answer. 300 root 61 kilometer. 300 root 61 kilometer. I hope you understood. Clear? So children, so in this mostly we discussed about the Pythagoras theorem. Based on Pythagoras theorem, its application part we have discussed in the questions. And here 12th question we have homework from exercise 6.5. I hope you understood. We'll meet again in the next session. Thank you.